Hello again, students. Today we are going to solve equations involving absolute value. So, you need to remember that absolute value means the distance a number is away from zero. All right, so absolute value, distance, we're talking about positive numbers. And the symbol for absolute value, okay, just two lines, and then whatever you're taking the absolute value of goes in between. All right, so a quick review. Absolute value, if we have the absolute value of negative 15, well, negative 15 is 15 away from zero. Absolute value of positive 1/8 is 1/8 away from zero. The absolute value of 0.25 or 0.29 is 0.29, but then the negative is on the outside, which means that this value would actually still be negative. Had that negative been inside the absolute value, it would have changed to positive. But this is saying you have to do order of operations and you treat absolute value like you do parentheses. Do that first, and then do anything that's left. So we do the absolute value of 0.29, which is 0.29, and then we negate it, take the negative. Same thing with this, we do the absolute value bars first, which the absolute value of negative 7/3 is positive 7/3. And now we're going to multiply that by 3. So this is going to give us 3/1. 3 on top cancels with 3 on bottom, which is going to give us just 7. All right, so here are some equations now. Okay, some unknown values, and we're going to use mental math. I think you guys are going to be capable of this, so if you want to test your knowledge, pause the video through each and see if you can solve each of these just using mental math. So the absolute value of a number, so this is saying what number, if you take the absolute value of it, is 16 away from 0. And you should come up with 16, but that's not the only answer. If you look on a number line, negative 16 is also 16 units away from 0. 2 times the absolute value is equal to 24. So 2 times what is 24? Well, that's 2 times 12. What's going to give you that's 12 away from 0? That's 12 and negative 12. The last one's the trickiest, the absolute value of x minus 3. So this time there's a value, a number that's inside the absolute value as well as the variable. So the absolute value of x minus 3 is equal to 8. Well, one easy one that you're probably thinking of right now is, well, 8 plus 3, to undo a minus, you add 3. That would give me 11. 11 minus 3 is in fact 8. But what about that other solution? Okay, we're going to come back to this. Notice how, for these, we were getting 2 solutions. And this one, we're going to get 2 solutions. You will almost always get 2 solutions because the absolute value, okay, is going to be equal to a positive number. But inside that absolute value, you could either have the positive version of that number or the negative version of that number. So you should have these 2 possibilities. The only time that wouldn't happen is if you have a number that doesn't matter if you put positive or negative in front of. So ask yourself what that number is. It's 0. Okay, positive 0, negative 0, still 0. But positive 1, negative 1, there's a difference. All right, so here are your steps for solving absolute value equations. Isolate, get the absolute value bars by themselves. So if there's anything else that's on the outside, undo it, just like you normally would for any other equation. Then write the expression inside the absolute value bars twice. Set that expression equal to the positive value and the negative value of the number on the other side of the equal sign, and then solve both equations. All right, so I'm going to come back up here. And I'm going to solve this equation right here using those steps that we just said. Okay, so here's one of my bars, here's the other bar. It's by itself on the one side of the equal sign. So now what I'm going to do is I'm going to write it twice. X minus 3, x minus 3. Then I'm going to set it equal to the positive version of what it's equal to and the negative version. All right, so then we undo minus 3 by adding 3 to both sides. We get x equals positive 11. We undo by adding 3 to both sides, and we get x equals negative 5. So there was our other solution. Let's do some more examples. So here's my absolute value bar. Here's my absolute value bar. It's all by itself. So we're going to go ahead and move on. So we're going to write 3x minus 3, or 3z minus 3, sorry. We're going to write it twice. We're going to set it equal to what it's already equal to on the other side, and then the negative of that. So that's negative 9. So how do we undo this? Well, z is attached to 3 by multiplication, and then we're subtracting this 3. So we get rid of what it's unattached to first. It's easier to do that in life, is to get rid of things that you're not attached to. So we're going to add 3 to both sides, and that's going to give us 12. Divide now to undo that multiplication, and we're going to get that z equals 4. Same thing over here. We're going to add 3, we're going to add 3. We still have 3z equals, but this time negative 3 plus 3 is negative 6. Then divide both sides by 3, and we get that z equals negative 2. So 2 solutions. And the way that you're going to write these, or type them into Alex, if your homework is on Alex, you're going to type in both numbers separated by a comma. All right, for this next one, here's the absolute value bar, here's the absolute value bar. Notice it's not by itself. We also have a plus 7, so that needs to go from the very beginning. So to get rid of a plus 7, we minus 7 on both sides. Now we're left with the absolute value of n is equal to 6. All right, so this one, we write what's inside the absolute value bar twice. We set it equal to what's on the other side, as well as what's on the other side and negated, which is negative 6. So nothing else for us to solve here. We get our 2 answers, n equals 6 and n equals negative 6. All right, once again, this one, our absolute value bars are not by itself. We're multiplying by 4, so we're going to need to divide both sides by 4. So these cancel, leaving us with the absolute value of x plus 1. Absolute value is equal to 16 divided by 4 is 4. So now that the bars are by themselves, we're going to take what's inside, x plus 1, and write it twice. We're going to set it equal to 4. We'll also set it equal to negative 4. To get rid of a plus 1, we'll subtract 1 on both sides. We can actually do this since it'll be the same process for both. We can do them both simultaneously. These cancel. This will give me x is equal to positive 3. These cancel. This will give me x is equal to negative 5. So x equals 3 and negative 5. This one, the absolute value bar, we are dividing it by 5, but we're also adding 3. Notice the divide by 5 is attached to the absolute value, so we'll get rid of what's unattached first. Opposite of a plus 3 is minus 3. So these cancel, giving us the absolute value of x plus 2, all divided by 5, is equal to 8 minus 3 is 5. Now we'll get rid of the divide by multiplying, so these cancel, and we'll have to multiply over here as well. So this is going to give us the absolute value of x plus 2 is equal to 25. Now that we have the bars by themselves, we write what's inside twice. We set it equal to the positive and the negative. All right, and then we're going to get x by itself. Here we'll have to subtract 2, and that'll give us x is equal to 23. We'll have to subtract 2, and this is going to give us x is equal to, sorry, this looks bad, negative 25 minus 2, that's negative 27. So this one, the 2 answers would be x equals 23 and negative 27. All right, the last couple of examples. Here we have the absolute value bar. This absolute value is equal to negative 6. So the absolute value is equal to negative 6. But remember, we said the absolute value, the distance away something is from 0, has to be positive. All right, so it's not possible for your absolute value bars to give you a negative result. That's not possible. All right, and so because it's not possible, that means we're going to write down no solution. So if you ever have your absolute value bars that are equal to a negative, so your absolute value bars equal to a negative, that's when you're going to have no solution. All right, so an example, this next example, we see our absolute value bars and we see a negative on the other side. So your intuition, you might say that, okay, that's not possible. However, there's a difference between this problem and this problem. This one, the absolute value bars are not alone. So you always have to get your absolute value bars alone first. So the absolute value bars, the sign in between negative 3 and the absolute value bars, there isn't one, which means it's multiplication. So to undo multiply, we're going to divide. We're going to divide both sides by negative 3. Negative 3 divided by negative 3 cancels, leaving us with the absolute value of 4n minus 1 is equal to, well, negative 6 divided by negative 3 is positive 2. So now we have our absolute value bars is equal to a positive, and that we can do. We take what's inside the absolute value bars and we write it twice. We set it equal to the positive, and we set it equal to the negative. Add 1 to both sides. That'll leave us with 4n is equal to 3. Divide both sides by 4, and we're going to get n is equal to 3/4. Over here, same thing, we will add 1 to both sides. That'll give us 4n is equal to negative 2 plus 1 is negative 1. Divide both sides by 4, and we get that n is equal to negative 1/4. So our two solutions, this one had two solutions because when we got the bars by themselves, it was equal to a positive. But here, when the bars were equal to a negative, that's not possible, so it's no solution.